how are you all? Today we are going to start our next chapter, that is three dimensional geometry. 10th में भी हमने कोऑर्डिनेट ज्योमेट्री पढ़ा है, उसमें हम डिस्टेंस फॉर्मूला यूज करते थे to find the distance between two points P and Q whose coordinates are x1 y1 z1 x2 y2 z2. To find the distance PQ, we use the formula x2 minus x1 whole square, y2 minus y1 whole square, and z2 minus z1 whole square. And we find area of triangle. इस चैप्टर में करते थे 10th में हम area of triangle find करते थे coordinate geometry में. Now in 12th we will use three dimensional geometry in line, for line and plane. So let us start with three dimensional geometry now. अगर हम three dimensions की बात करें, as it clears from name, three dimensions x, y and z. This is x-axis, y-axis and z-axis. The unit vector along x-axis is I cap, along y-axis is j cap, and along z-axis is k cap. If we want to find the position of a point in a space, किसी भी point की मुझे position find करनी है, then I should have these three axes, x, y and z. Suppose I have this marker. अगर मैं इसको यहाँ पे रखती हूँ, मुझे इसकी position find करनी है इस point के long, तो इसकी यहाँ से length कितनी है, breadth कितनी है और height कितनी है. So it depends on three axes x, y and z. And this is the point of origin O. So to find the position of any point in a space, first we have a fixed point O. Then from these fixed point O, we have three axes x, y and z, which are mutually perpendicular to each other. These three axes are perpendicular to each other. X, y and this is the z axis. Clear? Now we can define these as three terms, say length, breadth and height. Now in the next, अगर हम बात करें distance formula in 3D, अगर मुझे किसी दो points के बीच, suppose this is the point PQ, I want to find the distance between point P and Q. P has coordinate x1, y1, z1. This is in the Cartesian form, and Q has coordinates x2, y2 and z2. Then PQ is equals to square root of x2 minus x1 whole square, y2 minus y1 whole square, and z2 minus z1 whole square. So this is the distance formula in 3D. Now next, अगर हम distance formula की बात करें, if we want to find the equation of sphere whose center is HKL having radius R and coordinates of this point is x, y, z, then the equation of sphere is x minus h square, y minus k square, z minus l square is equals to r square in three dimensions x, y and z. Now if I want to know the examples of three-dimensional shapes, the shapes which are in 3D, cone is the shape in 3D, cylinder, cylindrical shape, cuboid, cube, sphere, prism, triangular prism is in the shape of 3D. This is the shape of cone, cylinder. So these are the shapes in three-dimensional space. Now if I have a rubber ball, suppose I drop the rubber ball vertically on a ground, then according to the room's length and breadth, I saw its position. When I throw it upward, then it again comes downward. So the point where it strikes the ground, its position from the length of room and breadth of room. Now if I know the height of the room, height of the wall above the roof, above the ground, then this is called in three-dimensional space. So wall is the example in three-dimensional space. क्या कहा मैंने, जब मैं बॉल को स्ट्राइक करूंगी ग्राउंड पे, देन इट गोज वर्टिकली अपवर्ड्स, वर्टिकली अपवर्ड हमने बॉल को थ्रो किया, आफ्टर दैट इट कम्स डाउन, देन इट स्ट्राइक्स द ग्राउंड एट अ पर्टिकुलर पॉइंट, एंड दैट पर्टिकुलर पॉइंट लेंथ फ्रॉम द रूम एंड दैट्स ब्रेथ फ्रॉम द रूम. और अगर मुझे बॉल की हाइट भी पता लग जाए तो दैट विल बी इन थ्री डायमेंशनल स्पेस. वी कैन से लेंथ, ब्रेथ एंड हाइट. So this is about height. If I say the height of the wall is 2.5, length is 5, breadth is 4 and height is 2.5, then I can write it as this. For dimensions for the ball, I can write like 5, 4 and 2.5. It is length, breadth and height. So this is in 3 dimension. Now example of अगर हम cube देखें, dice. Dice is also example of three dimensional. अगर हम रूबिक्स क्यूब की बात करें, then it also has length, breadth, and its height is also there. So it is a three-dimensional shape. This, and its height. Suppose its height is there. So this is the height of this. So Rubik's cube is another example of three-dimensional shapes. So now let us discuss about the formulas which we will use in this chapter. If I want to write the vector for a point, then I will write it as xi plus yj plus zk. I cap, j cap and k cap are unit vectors along x, y and z axis. So if I want to write in the vector form, then I will write it as this. And if I want to write the point in the Cartesian form, then I, j and k, these vectors, unit vectors will not include it. So this is the point in the Cartesian form and this is the point, say point A in the vector form. So let us start with some formulas. सबसे पहले हमने पढ़ा distance formula. Distance between two points, if I want to find, it is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. अगर हम नेक्स्ट फॉर्मूला की बात करें, सेक्शन फॉर्मूला. सेक्शन फॉर्मूला, लेट आई हैव टू पॉइंट्स a and b whose coordinates are x1 y1 z1, x2 y2 z2. If there is any other point, say c, which divides line segment AB internally in the ratio m1 ratio m2, then what are the coordinates of point C? That will be m1 x2 plus m2 x1 upon m1 plus m2, m1 y2 plus m2 y1 upon m1 plus m2, m1 z2 plus m2 z1 upon m1 plus m2. This is the first case when the point divides the line segment internally. So first case, when C divides AB internally. Now second is the case when C divides AB externally. अगर ये C जो point है AB को externally divide करता है in the ratio m1 ratio m2, then what are the coordinates of point C? Then coordinates of C will be m1 x2 minus m2 x1 upon m1 minus m2. Similarly for y and z coordinates, minus m2 y1, m1 minus m2, m1 z2 minus m2 z1, m1 minus m2. Now third is the case when C is the midpoint of AB. When C is midpoint of AB. Midpoint means it divides it into two equal parts. C is dividing the line segment AB in two equal parts. Then the coordinates of C will be x1 plus x2 by 2. A has coordinate x1, y1, z1. B has coordinate coordinate x2, y2, z2. Then coordinates of C will be x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. Now if I have a triangle ABC with coordinates x1, y1, z1, x2, y2, z2, x3, y3 and z3. Now G is the centroid of the triangle. Then what will be the coordinates for the point G? Centroid of triangle has coordinate x1 plus x2 plus x3. Since the triangle has three sides, so x1 plus x2 plus x3 by 3. Similarly, y coordinate y1 plus y2 y3 by 3, z1 plus z2 plus z3 by 3. So this is the centroid of the triangle. Note up to here. Now let us talk about the direction cosines and the direction ratios. So these are the general formulas which we will use in solving the questions. Now next I have position vector. Suppose I plus 2j plus 3k. This is position vector of any point. Then what will be the value of x1, y1 and z1? हमने लिखा था पहले वेक्टर को हम किस फॉर्म में लिखेंगे xi plus yj plus zk. Now x component is here is 1, y is 2 and z is 3. So these are the points. Now if r vector is I plus 2j plus 3k, then the direction ratios of r, direction ratios क्या होंगी इसकी? Direction ratios को हम किससे लिखते हैं? A, B and C. A is 1, B is 2 and C is 3. A is 1, B is 2 and C is 3. If I have 2 points A and B with coordinates x1, y1, z1, x2, y2, z2, then what is the direction ratio for AB? Then what is the formula to find direction ratios of AB is x2 minus x1, y2 minus y1 and z2 minus z1. So the direction ratios will be x2 minus x1, y2 minus y1 and z2 minus z1. Now if the direction cosines are proportional to 1, 2, 3. Suppose we have any vector whose x, y and z coordinates are this. Then what is the, if direction cosines are proportional to this, it means direction ratios. These are direction ratios. A as 1, B as 2 and C is 3. Now if we have direction cosines are 1, 2, 3, not proportional to, direction cosines are this, then these are the value of L, M and N. We denote the direction cosines by L, M and N and direction ratios by A, B and C. Now we have formulas for the direction cosines. A upon square root of A square plus B square plus C square. B upon, this is value of L. M is B upon square root of A square plus B square plus C square. And N is C upon square root of A square plus B square plus C square. If we have given direction ratios and we want to find the direction cosines, then we will use this formula. Now if the angle is given, if a line makes an angle alpha, beta and gamma with x, y and z axis, then direction cosine L is equals to cos alpha, M is equals to cosine of angle and n is equals to cosine of angle gamma. And we know that one identity, that is L square plus m square plus n square equals to 1. If we have given the angles and we want to find the direction cosines, then we will use this formula. L is equals to cos of alpha, m is cos beta and n is cos gamma. And if I eliminate our direction cosines, then L square plus m square plus n square equal to 1. Now angle between two vectors, in terms of their direction cosines. In terms of direction cosines, let A vector and B vector, let A vector and B vector be two vectors with direction cosines L1, M1, N1, L2, M2 and N2. I have these two vectors and I want to find the angle between this. Let theta is the angle between A and B. Theta is angle between A vector and B vector. Then cos of theta. What is the cos of theta? Angle between these vectors is equals to A vector dot B vector upon magnitude of A, magnitude of B. If we take dot product, then what we get? L1, L2, M1, M2, N1, N2 upon magnitude of A vector, that is L1 square, M1, N1 square, square root, and similarly magnitude of B vector is square root of L2 square, M2 square and N2 square. Now the condition when these two vectors are perpendicular, when A vector and B vector are perpendicular, when A vector and B vector are perpendicular, हमने वेक्टर चैप्टर में पढ़ा था पिछले में, वेक्टर्स में डॉट प्रोडक्ट, क्रॉस प्रोडक्ट और स्केलर ट्रिपल प्रोडक्ट के बारे में. If two vectors are perpendicular, then their dot product is 0. It means A dot B is 0, but we have the value of A dot B, L1, L2, M1, M2 and N1, N2 equals to 0. Now if these two vectors, A vector and B vector are parallel, when these vectors are parallel, then what is the condition? Then A vector is equals to constant into B vector. Two vectors are parallel if they have same position vectors instead of the constant term. The only difference is constant. If we take anything common from the other vector and the rest position vector is same in both the cases, then we say these vectors are parallel vectors. So A vector is equals to B vector, that is L1 upon L2 is equals to M1 upon N2 is equals to N1 upon N2. Then it will be equal to any constant, say lambda. Then this condition for the vectors when they are parallel. And if the direction ratios are given, if I have given the direction ratios, let A vector as A1i, B1j, C1k and B vector is A2i, B2j and C2k. Then cos theta is, instead of direction cosines, here we get the values of direction ratios A1 A2 plus B1 B2 plus C1 C2 upon square root of A1 square, B1 square, C1 square and square root of A2 square, B2 square and C2 square. So when the direction cosines are given and when the direction ratios are given, then we will apply these formulas. और अगर इसमें direction ratios are given and A vector and B vector are perpendicular, then what we get is at of L1, L2, M1, M2, N1, N2, we get A1, A2 plus B1, B2 plus C1, C2 equals to 0, and here we will get when the vectors are parallel a1 upon a2, b1 upon b2 and c1 upon c2. Projection of line segment joining two points P having at points x1, y1, z1 and Q having coordinates x2, y2, z2 on a line whose direction cosines are line with direction cosines L, M, N. Then projection of this line segment on the given line will be x2 minus x1 into L plus y2 minus y1 into M plus z2 minus z1 into N. The next topic we are going to start is the line. लाइन के बारे में पढ़ेंगे हम सबसे पहले. लाइन की अगर हम बात करें तो हमने वेक्टर और कार्टेशियन फॉर्म ऑफ लाइन बतानी है सबसे पहले. लेट